Hello, my name's Clinton, and I'll be your guide through this module of Day 5. We're going to talk about polynomials. Please don't forget to pause this presentation at any time if you need a bit more time to think about something. Polynomials are the most important family of functions in mathematics. You've seen polynomials before. They're just sums of powers of some indeterminate x with numbers in front of them. The numbers in front of the powers are called the coefficients of the polynomial, and the largest power of x which appears in the polynomial is called its degree. For example, this polynomial has degree 3. Notice that it has no x term. Alternatively, we can just think of x as having a coefficient of 0 in front of it. Polynomials of degree 3 are also sometimes called cubic polynomials. This polynomial has degree 4. If we have any number, we can plug this number into a polynomial by substituting it for x to get some other number. Of course, what we're really doing here is thinking of the polynomial as a function. We plug in a number x, and the function spits out the polynomial evaluated at x. If we can find some number x that gives 0 when we substitute it into the polynomial, we say that this number x is a root, or solution, of the polynomial. A polynomial of degree n can't have more than n different roots, but some may not have any at all. If you ever study complex numbers at university, you'll see why this is true. For example, this polynomial, x to the 4 plus 1, has no roots. Try and find a number which you can plug into it and get 0. The polynomial x to the 4 minus 1 has 2 roots though. If you take either 1 or negative 1 and raise them to the 4th power, and then take away 1, you'll get 0. We'll be able to show later that more complicated looking polynomials like this have 4 distinct roots. You've seen long division of numbers and probably of polynomials before. For quick revision, remember that if we have two numbers a and b, with a bigger than b, we can divide a by b to obtain a on b equals some whole number q plus some remainder r over b. For example, if we divide 25 by 6, we have 4, and since 4 6s are only 24, there is 1 left over. So 25 on 6 is 4 plus 1/6. Or you might have said 25 divided by 6 is 4, remainder 1. We can do a very similar thing with polynomials. If we have two polynomials f and g, where the degree of f is bigger than the degree of g, we can perform a long division of polynomials to write f on g as a polynomial q plus some remainder polynomial r over g. It might look a little tricky at first, but it's really the same procedure as with numbers. Let's divide x squared minus 3x plus 2 by x minus 1. First, write the polynomials fx and gx here and here, just as we do for long division of numbers. Divide leading terms by one another, so here we divide x squared by x to get x. Multiply x minus 1 through by x and write the result on a new line. We want to find the difference of the line x squared minus 3x plus 2 and x squared minus x, so we subtract, and notice that the x squared cancels, and we're left with minus 2x plus 2. Now we repeat the process, and divide the new leading term, minus 2x, by the leading term of x minus 1, which is x, to get minus 2, which we write next to our existing x on the top line. Now multiply this minus 2 by x minus 1, and write the result, minus 2x plus 2, on a new line. Subtract, and notice that this time everything cancels to 0. This means that the long division is finished, and so the quotient is x minus 2, and the remainder is 0. So x squared minus 3x plus 2 over x minus 1 is x minus 2. Multiplying both sides by x minus 1 gives a factorization of this polynomial as x minus 1 times x minus 2, which we might have seen by using the quadratic formula, for example. See if you can work through this example of dividing 2x cubed plus 4x minus 3 by x minus 2. Press pause, and then press play when you want to continue. You should see that the quotient is 2x squared plus 4x plus 12, and the remainder is 21, so we can write the expression like this. You can always check you've got the right answer by putting the right-hand side over the common denominator x minus 2 and expanding everything out. Here are some practice questions involving long division of polynomials. Press pause, and then press play when you want to continue. Here are the answers.